All right, algebra class, here we are, 9-3, graphing quadratic functions. Now, we did do a little bit of graphing before, but it was more simple things. So, like when you look at this equation down here, it didn't have all this. It was just something like y equals 3x squared. And we made a little xy chart with -2, -1, 0, 1, 2, and we plotted the points. Okay, gets more complicated when you have a longer train of things to substitute in. So kind of like when, let me just flip this over, this is your warm-up, but I'm going to use it for something else. Kind of like when we would have y equals 5x plus 2. And yes, you could make an xy chart, or you could plot the what? What is this? The y-intercept. And we would go and find that on the y-axis. And then from that, we would do the rise 5 run 1, right? Because that's the slope. So 1, 2, 3, 4, 5, and run 1. And we would have our line. Okay, because we would plot that and then do the slope. Well, we're going to learn some things like that with quadratics now, so that you can do things a little bit shorter sometimes than making these XY charts, which, depending on if you have different fractions and things in here, it gets just more complicated. So I want you to hone in right now on this, because I'm going to carry this part over to quadratics, because guess what? It's the same. So back to this. Let's look at the top here. I'm going to go back to the actual first sentence here in a second. I want to start with this first. What is the y-intercept? You just did that on the other side. The y-intercept, when we had a line, y equals mx plus b, it was the number that was all by itself. Guess what? When you have y equals ax squared plus bx plus c, guess what the y-intercept is? The c, the number that's all by itself. That is the y-intercept. Okay, because it's basically saying that x is 0. Right? If it's on the y-axis, that means that x is 0. It's right in the middle. So if x is 0 and x is 0, those two fall out. So whatever this is your answer. So let's look at this one. What's your y-intercept, class? Well, what's your a? Your a is 1. What's your b? No, it's not -2, it's 0. There's no x term in here. Remember, b is before the x. What's your c? -2. That is your y-intercept, -2. What's your y-intercept here? A is 1, b is -4, c is 4. There's your y-intercept. What's your y-intercept here? A is -2, b is -6, and c is -3. No, you don't have to write the a and the b to just pull out the c there and know the answer. But when we're getting axis of symmetry, we need a and b. So ultimately, you do use all three of these. Okay, so let's practice now. And I have on here at the bottom, okay, that's just in my way, so hang on. At the bottom, I have a list of the steps. And I try to give you a format so that it's not so abstract. I try to give you actual steps to take to graph. And if you follow the steps, voila, you've got the graph. Okay, so the first step is make sure this is in y equals form. So that one is, as you notice, that one is not. So when we get there, we're going to have to get that y alone. So first we're going to do step 1, find the axis of symmetry. You know the formula. It's x equals the opposite of b over 2a. And let's just go over here and write what a is. A is 3, b is -6, and c is 1. So plug those in. Opposite of b, -6 is a +6 over 2 times 3, 6 over 6, x equals 1. Now put that on your graph. So x equals 1 again is a vertical line. So we're going to find 1 right here. And you know what, just to make it, I'm going to use these bigger dashes as my 1. So I'm just going to darken those in. I'm going to go by those as 1, -1. Okay. So go to 1 and you're going to draw it, use your straight edge and draw your vertical axis of symmetry. Now you need to find the vertex. Remember, the vertex is somewhere on that green line because we know the x is 1. We put that in there. Now we have to substitute that 1 into our equation and see what the y is. So y equals 3 times 1 squared minus 6 times 1 plus 1. 1 squared is 1 times 3 is 3. Minus 6 times 1 is 6 plus 1. Y equals -3 plus 1 is a -2. And we have our answer. So 1, -2. And again, I'm going to go by those bigger chunks as my 1s. Hopefully I don't regret that. All right, so 1, -2. I go 1, -2, and yep, it falls right on there. Now you see that this is positive. We learned that that tells us something. Does this mean this is going to go up, or is this going to go down? It's going to go up. It's positive. So we already know it's going to curve up. The next step, as you see, is to get the y-intercept and then reflect it. Well, the y-intercept is already up here. Where is it? Right there. C equals 1. That is my y-intercept. 1. So go ahead and put that on there. Find your y and put a point at 1. Okay, that is my y-intercept. Now I'm going to reflect it. So when I say reflect it, I mean we're going to go up and find this dot, reflect it over this symmetry line. So count over. I go 1 over, I'm going to go another 1 over here. Because already, look at the form we're taking here. We already can have the outline of our parabola. Now we just have to do one more thing, and that last thing is to find another point and reflect it. So instead of doing an XY chart where you have to get 5 points, we just have to pick one more now. So deciding what point to pick depends. I kind of look here and I'm like, well, I already have this, and I have 1, I have 0, 1, and 2 already covered. I'm going to do 3 because it's positive, and I'm just going to try it. So we're going to pick 3 for the x, and we're going to substitute it in like we did here and figure out the y. So I picked that. You could have picked something different, but if you get too big, it goes off your graph. This might even go off the graph. Let's see. Y equals 3 times 3 squared minus 6 times 3 plus 1. Y equals 3 squared is 9 times 3 is 27 minus 18 plus 1. And y equals 27 minus 18. What is that? My brain is not working. 9 plus 1 is 10. That is your y now. So I put that up here. And there's my other point. So I have a point to put, and then I will reflect that one as well. So let's go back up here. I'm going to put this one in a different color so you keep them straight here. This is going to be my blue one. So 3, 10. Oh dear, we're way off. 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, class, I'm way up here. That didn't work like I planned. Let's extend that line up. Then you would reflect this over here. How's that for a parabola? All righty. So now we're going to go down and back up. Okay. Anywho, you get the idea. Let's try another one. I can tell I shouldn't have gone by using the bigger markers because then it would have fit on there because I would have been able to get up to 10. So that's my fault. We're going to try one more. And I'd like you to, once I get you started here, to try to stop it and try it yourself. But the first thing we have to do is get this y alone. So I'm going to subtract the 6x on both sides. And then write this in descending order because none of these are like terms. So I'm going to have y equals the x squared first minus the 6x plus 9. I'm just going to highlight that so our eyes kind of focus in on that. And highlighters can be really helpful. And write them here. A equals what? 1. B equals -6. And C equals 9. All right, so go ahead. Get your axis of symmetry vertex. See if you can do it. And then pause the video and then come back and see if you got it right, okay? Meanwhile, I'm going to continue on. Axis of symmetry, x equals -b over 2a. The opposite of b, it's a -6. So a -6 over 2 times 1 equals 6 over 2 equals 3. X equals 3. I'm going to go graph it, and I'm going to not count by the bigger dashes this time. 1, 2, 3. Draw my line right through it. It's always vertical. Always vertical. Use a different color, guys. If you use pencil, it blends right in with the rest of the graph, and all of a sudden you're going to be reflecting over this instead of the right line. So graph it. Now, vertex. We're halfway there. We already have the 3 for our x. I just have to substitute that in to my equation to get my y. Y equals 3 squared minus 6 times 3 plus 9. Y equals 9 minus 18 plus 9. -9 plus 9 is 0. Okay. I got my vertex. 3, 0. We know it should fall on here, and it does. It's right there. Y-intercept. Where is my y-intercept, guys? Right here. So go to your y-axis and put a 9. Put it on the 9. 1, 2, 4, 6, 8. 9 is right here. What else does it say to do after you get the y-intercept? It says to reflect it. Reflect it over what? Reflect it over that line you drew. 1, 2, 3 to the line. 1, 2, 3 away from the line. Okay, so when I go ahead now to do this other point, I want to talk about this because in the last one, I had gone outside of this. But in this one, I've got this space in here that doesn't have a line or a point in here. So I'm going to pick 1 or 2 because I got 0 and I got 3, but I don't have 1 or 2, and those are easier numbers to work with. If I go outside of these digits, it's going to be way off the graph. Okay, so let's pick the 1. I'm going to pick 1. So I literally am putting a 1 for the x, and now I'm going to figure out what the y is, just like we did right here. So 1 squared minus 6 times 1 plus 9. Just substituting it into our original equation again. y equals 1 minus 6 plus 9. Y equals negative 5 plus 9 is 4. 1, 4. Okay, there we go. I'm going to use a different color. I'll use this green. So 1, 4. So 1, 1, 2, 3, 4. Now reflect it over what? Not the y-axis, guys. Everything's about this pink line here. 1, 2, 1, 2. And there it is. A sight to behold. So cool. So just make sure that you follow these and understand each of them. And it's kind of all laid out for you. No, I don't give you too many in your homework. I give you enough so that you're practicing, but I do want to do one applied problem first here. And that is about a soccer ball. Okay, so again, you're going to find out here that we have the height of in feet of a soccer ball can be modeled by this. So they give you the quadratic, where x is the time in seconds after it is kicked. Okay, so I'm going to go down here and put that by my x. That's my time in seconds. Okay. After it is kicked. Find the soccer ball's maximum height. Okay, so that's my y, my height. And the time it takes for the soccer ball to reach that height. Then find out how long the soccer ball's in the air. Wow, we've got a lot. So we have to find the max height. We have to find the time it takes to reach that height. Then we have to find how long the soccer ball is in the air. So we have 3 different questions here. Again, whenever you're doing this, getting a general idea of the quadratic, I'm going to just write it right here. Since we have the quadratic, we can find that height. We can find the maximum. We can find the top of our quadratic. How? Well, let's start graphing. Let's first step it. Axis of symmetry. X equals opposite of b over 2a. All right, well, let's first tell us what is our a, b, and c here. What's a? Negative 16. B, 32. C, 0. There is no c term. Okay, so the axis of symmetry is opposite of b, which is a negative 32, over 2 times the negative 16. Negative 32 over negative 32, 1. Yay! X equals 1. I'm not going to regret it this time, I promise. I'm going to make this bigger, so I'm going to go by the 1 there. All right. Draw my line. This is my 1. All right. X equals 1. Now, what's the next thing we did on the other page? Vertex. That's going to tell us everything. Once we get the vertex, we are set. So X is 1 right here. So I put that into my vertex, 1, and find the Y. So I just have to plug it in. So we're going to find f of 1 equals negative 16 times 1 squared plus 32 times 1. So f of 1 equals 1 squared is 1 times that is a negative 16 plus 32. F of 1 equals 16. Because that's like your y, isn't it? So 116, 1, 2. I'm going to go by 2's up here. 2, 4, 6, 8, 10, 12, 14, 16. I'm still off the graph. 116. Okay. So we're kicking this off. We know the y-intercept. It's 0. It's right here. The ball is being kicked. And the ball is coming down. I don't like this graph. This is a terrible graph. I'm making my own. There's the first quadrant. Let's just say this is 1 and this is 16, just so I can show you. 1, 16. That's the top. So they kick the soccer ball up and it comes down. Not symmetrical at all, is it? It's okay. I'm trying. There's my symmetry line. You figured it out. This is 1, 16. You have everything you need now to answer all the questions. Okay, let's find out what they asked. Find the soccer ball's maximum height. Okay, this is the maximum height, even though it doesn't look like it because my picture is terrible. How tall is it? Well, remember how you're getting 116. You're going over 1 and you're going up 16. The maximum height is 16. What? What are we talking in here? Feet. Done with that. And the time it takes to the soccer ball to reach that height. Well, so when it got to here, how much time ticked by? It's right there. 1 what? What are we talking? What's the unit in here? Seconds. That's 1 second. So that time was 1 second. Then find out how long the soccer ball is in the air. Okay, so we kick it, it goes up, and eventually it hits the ground here. Well, remember, this is a symmetry line. So if it's 1 second from here to here, guess what it is from here to here? 1 second. So what was the total time in the air? 2 seconds. Oh dear, that's not my phone. Did you guys hear the screaming? Okay. So there we are. We answered all the questions. And again, super cool the way we can use these situations to, these quadratics, or anything you kick, drop, any kind of arcs, all quadratics, all engineering, really neat stuff. So, all right, we'll see you soon. Bye.